Good evening. My name is Ricardo Camacho. I'll be explaining the entity relationship diagram for our chosen domain, University Course Management System. The purpose of this database is to support the core academic operation of a university. The scope of this system is focused strictly on academic record management. Non-academic areas are excluded. Now, the main entities in this database are student, lecturers, course, department, and enrollment. Students store personal information, contact, lecturers store academic qualification, teaching details, and their personal information. The course stores academic requirements and credits value. Department organize both courses and lectures within the university structure. One of the key design challenges in this system is the many-to-many relationship between the student and course. A student may enroll into multiple courses and a course may have many students. To correctly model this relationship, an associative entity called enrollment is used. The enrollment entity links a student to a course and stores information that only exists when a student takes a course, such as enrollment, grade, and attempt number. Including the attempt number allows the system to track repeated course attempts. Another important design of this diagram is the department ownership. Every course and every lecturer must belong to exactly one department, enforcing academic structure and accountability. At the same time, lecturers can teach multiple courses, allowing flexibility in teaching. The database provides a structured and realistic model of a university academic operation, ensuring data integrity and supporting for key academic role.
Group member Chinish. So for this project's relational diagram, it represents a comprehensive model including two interconnected sections focused on the student, course, and instructor tables. These tables are interlinked through the enrollment and teaching junctions, where the enrollment captures the association between students and courses along with their respective grades and timestamps. Additionally, assignment and submission tables are integrated with course and student to facilitate tracking of tasks and their outcomes. The overall design includes foreign keys to maintain referential integrity and primary keys for unique records identification. The relationships are depicted by arrows that denote one-to-many and many-to-many connections, extending into the second segment to clarify composite keys and progression rules. This specified framework effectively supports functionalities such as registration, grading, and reporting.
Okay, so this is our um, SQL or the project. As you can see, our database is shown here. The tables are all lined up here with all the stuff inside for each table, and our schema is shown here. This is what we use to create all of the tables. Let me just do a little quick to show you how the tables are working so that you can see that everything is as is. As you can see, this is our enrollment table with everything listed. It goes down all the way to 2000, 2000? No, it goes to 1000 records slash insert. And this is our department table. As you can see, our 14 departments. These are our students. As you can see, it goes on till 2000. Our course table goes on to 400. And last but not the least, our lecture table. And it goes down to, we made use of this is our SQL generation of the data for the inserts, our C program for it. It automatically generates a large amount of realistic data. At the beginning, we have our to lowercase. This is used as it is used to generate email addresses by converting the name to lowercase, as the name says. We made use of a lot of standard C libraries, as you can see here, the main one, of course, and then for string, for C type, etc. There's also a lot for the file handling, string management, etc., as you can see. Later on, we make use of the name track, which is used to track and generate the lecture names, as we had a lot of issues where a lot was repeating. So this kind of avoids that and helps to ensure that, it's being checked before everything is being added to the insert values. The is named function is used to check whether it already exists. And then, yeah, this is just what our file is named. If it's not named that or they cannot find that, then it will show an error. And this is, of course, just using the database university, which is our database. Then we have our main stuff for inserting into department, etc. And it just continues like that. We have our chart names so that this will randomly allocate a name and a last name for the values, 2000 to 1000 values. We have qualifications. They're choose based on the students, departments, etc. I'm just gonna run it quickly because we don't have that much time. But as you can see, it works, and then it just gives you all of this, and that is what we copied into here, and it creates our diagrams very fast first. This is one example of our queries. We don't have much time to go through all, but this basically we used, so it's like a select count, which would basically look through student, and it will see what their department ID is and compare it to the department ID. So let's say their department ID was 1 And of course, if it equals to 1, then it will give a total tally of the students. And hence you can see our tally here, and same goes for the rest. We made use of a round function, of course, to showcase the average. And that's basically it when it comes to queries. We made use of a lot of order by, and so to join everything together.